This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. Okay, so yeah, so like yesterday we were trying to talk about some charts, right? Some sets basically, right? So we're just going to continue the same thing. So how do we do that is, are we just going to continue the same thing, and that is going to be uh, um, that's going to be like changing or some more options around that, and majorly around deployment. Okay, so we're going to talk about that as well. So first, let me. I'm actually trying to review what we have done so far. Let me. Yeah. So in the pods, I'm just seeing, is a kind of health checks are being covered. So something we missed actually. All right. So that's not a problem. I will go with that. So there is something called as health checks, which I missed that particular part. Yeah. Somehow. Okay. All right. So yeah, we'll talk about that as well. And system is kind of humming. Okay.
Hello, your voice is breaking.
Yeah, my system is a kind of it's not responding. I'm just seeing someone wanted Windows now. So I think it's now it is kind of okay. Is my voice okay now?
Yes, you can hear now.
Yeah. Fine. All right. Okay. Let's respond a bit. Okay. So let me pause the notifications. Okay. Fine. All right. Yeah. So let's go with the same stateful set, and when you and when we are talking some points yesterday, so we talked about something called as a change in the, so when you change the application, so how it is actually going to behave, right? So it actually goes with one by one node is what we talked about, right? So let's go and try to do that. So so CDSS, so probably you have 01.yaml. So let's say that you have one file, right? Yeah. Okay, all right. So let's go to this now. My system is really, it's not responding at all. Oh, what's happening? Okay, so here you have one version, like let's say, and probably rather than this, I would say Nginx different versions. So or hub.docker.com. So different image versions. Okay. So if you see the multiple versions here, you have 1.18, you have 1.19, you have, right? So I would like to go with and let's say that it is this one is Nginx 1.18. Okay. So push these changes and git space pull and kubectl apply -f apply -f 01.yml file. Now I'm going to get so stateful set is created, kubectl get space pods. Yeah, so it slowly comes one by one. Now the first one is coming, and so it's actually going to be pods. Yeah, the first one is going to come. The first pod is coming. Once after this is up, the next one will come. So we already seen this. Let it come. So then when we update the newer version, so how it is going to behave. So that's what we're going to see. So the second one is actually trying to come up. The second one is also up. So it's going to third one. The third one is also up. Okay, will be up. Now you need to understand the behavior. What is the behavior you want to understand is when you update. Okay, I am going to say now I want 1.19 version. Okay, I'll update the change. People. So kubectl apply -f 01.yml file. So now you can see this one by one it is going. First one it went through, and after that the second one is actually coming up, or it went through the third last one probably. It started with this one. Okay, but it goes one by one. Okay, and this is a quite important order you need to understand here. So why it is actually okay, so how it is actually happening. So it goes one by one, one by one. Now let's say if I go back and so put to 1.18 and change this and go for git space pull and just give kubectl apply this one. After pulling it, now if I go for K9s, you see this, it just goes first it is doing is it is terminating web2, then it is going to create web2, then it try to understand it's terminating. Okay, so that means one capacity is going down and bringing the new one, and another capacity is actually going down again coming up, and that way it is actually happening, right? So that is that is how it is behaving, right? So that's a behavior. Okay, so the behavior is quite important in choosing, so the choosing how to deploy or what to or so what is your requirement, kind of thing. So your requirement is going, so one by one, something like that. In that particular case, we always go for okay, um, I mean, you can go for stateful set. Basically, the deployment is actually, or the new changes is happening one by one, one by one, one by one. Okay, it's going in sequential, not parallel. Okay, but whereas the replica set, which we seen yesterday, it's gonna just happening in parallel. Okay, so that is what is the difference. All right. Now today, let's go with something called as a deployment. Okay, let's talk about deployment. So let's go with deployment in Kubernetes. Okay, so deployments Kubernetes, and what the documentation is telling here is yeah, a deployment provides the declarative updates to pods and replica sets. Pods and replica sets. So what actually the problem with the replica sets? Let's see first the problem with the replica set. Let's go here cd.r and ls cd rs, and first of all let me see in the rs what is the image I have. So let's go for nginx:1.18, the lower version, and nginx. Okay, let's push this. Okay, someone is bugging me. Okay, so kubectl apply -f and kubectl apply -f and 01.yml file. So if I go with K9s and you will see, so the two front end, or let's go with some 10 number, okay, so that you will get some understanding. So let's go with some 10 number and git pull. Done. So K9s, you're going to see the 10 pods now, right? Let me open another session to the same server. Now the problem, try to understand, the problem is I'm actually, see the stateful set, when I updated the version and when I applied it, so stateful set is actually recognizing those particular changes and is trying to update it. Okay, but now, so here you do the same thing to, so you do the same thing to this guy, which is replica set. So he will not bother about that. kubectl apply -f 01.yml. So you apply the replica set changes. On the top, can you see something? Nothing is happening. Nothing is happening. You change some specification inside the replica set, it will not get impacted. Okay, but as a part of CI/CD process, what we generally do, we update the versions all the time. We update. We'll move on from one version to another version. Okay, so that is where we need a yeah, so that is where we need someone who can do this, and that's where the deployment comes into picture. Actually, I'm doing pausing and doing, okay, if you can give me 2 minutes or at least let's say 5 minutes, probably I can complete some work and come back. People are behind me.
This conference will now be recorded.
All right, so now what is the problem you have seen? The front end replica set is not actually detecting any changes. Okay, and in the process of continuous deployment, okay, so what we usually do, so we generally update the versions, right? So when I update the versions, then what's going to happen is it should get affected. My pod should come up, so scale up and scale, so I mean a new deployment should happen, and that is what is expected, right? And that is where it cannot be done, and that's where the deployment come into picture. So deployment provides a declarative updates to pods and replica sets. You do some updates to your pods and your replica sets, and yeah, it can okay, so detect those particular changes, and it will try to um, apply those particular changes. And in which general cases, the use case of this particular one is, so when you want to go for a rolling update kind of thing, okay, roll out a replica set kind of thing, so then you go for deployment. Okay, so if I just go with the deployment in Kubernetes, if I go with some guys or documentations, so what usually happen here is it's just going to create let's try to create one deployment so I can show you. So first thing is I'm going to take this. Okay, so here new which is going to be deploy, and so the deployment is this, and the replicas is okay. So 1.14 is what you have, okay, which is fine. All right, so I just want to push this, and so kubectl delete -f 01, the replica sets I just deleted, all the pods will get terminated. And also kubectl delete -f // it's a /01, so which is a stateful set. So these also will go away on the top. All these also go away. Fine. So we have a deploy now. So git space pull cd deploy ls and kubectl apply -f01.yml. And if you look into the configuration, I mean, you look into the YAML file, you know, there is nothing changes here other than you change this as a deployment. Everything is as simple as your replica set. Only the thing you say here is deployment. That's it. Everything is same. Okay, not even a single line difference. Now you can see this, it is actually creating okay, it is creating a 3 pods because you asked for that. Now in the backend, what actually will happen is this comma pod, will it work? No. So if I go with the replica set, what actually deployment does is deployment will create one replica set. Deployment will create one replica set. Now what I'm going to do is the current deployment actually replica set, if you see if 656 ending with 656, if you see that particular number or the string, it is actually pointing to 33. Now what actually if you do, if I go back here and I say 1.15 and I push the changes, and if I go and give git space pull and apply the changes, pull the changes and apply the changes, so then what it does is it creates one more replica set. Okay, and it slowly scale one by one. Now currently it is 1. Okay, 1 is done, it comes to 2, it comes to 2 plus 1 at the down, -1 at the top one. So +1 it does here, -1 it does here. Okay, so that is how, okay, it just balances the replica set. So what it does is it just changes the pointer to the new replica set. Okay, so that's what it's going to do. So you're going to have one replica set, the deployment is pointing to this, and when you ask for a new change, so then it creates one more replica set and transfer the number to here. Number means, like, let's say you have 3 pods here. So first it creates one pod here, -1 here. Okay, it creates a second pod here and -1 here. Okay, it creates a third pod here, so it becomes finally 0 pods. But the replica set will be there. Replica set will not be deleted. The replica set will be there. So that's where your pods and all will, you know, come back as newer versions. Okay, now if you see here, so kubectl, now let's say if I go to 6 version, 1.16 version, and if you see the pods and how it is actually going to happen is +1, once that 1 is done, then it goes to -1 of the old one. If you see this, the new container is getting created, and once that come to running, the existing one will get terminated. The existing one is getting terminated. So the old one is actually, you know, come to running, and the second one is actually coming to running. So, you know, like this, one by one it came, and the old deployment is gone. Old deployment is gone. So this is the default procedure of the deployment. Okay, so which the mechanism of the deployment, we call it as a rolling update. So what are the different types of deployments which you have? Deployment strategies, DevOps. If you go there, generally if you see this, a variety of deployments. So you have something called as recreate. What is recreate? So I have okay, so I have 2 versions, like, let's say. So first version is terminated completely, and then version B is rolled out. So generally we don't prefer this. Why? Because, you know, there is a downtime involved. There's a downtime involved. And whereas we go for rammed one. Rammed one is also nothing but rolling update. Okay, so version B slowly rolled out and replacing version A. So version A, okay, will slowly be replaced by version B. You have already seen that, right? Immediately everything is not getting changed. Slowly it is going. Okay, so since it is only 3 pods, you are not actually seeing some difference. Okay, or else you can also use the earlier one, which is the stateful set deployment is also rolling update. Slowly one by one is happening, right? So yeah, that's it is. And So the next one you have is blue green. So that means version A will be there, version B will be there. You toggle between them. Okay, we probably can see that later. And canary is another type of deployment. So which you're going to have version B is released to a subset of users and then proceed with the full rollout. So some percentage of users will go for canary and some percentage of users will get and some persons will get version A, some persons will get version B, something like that. So A/B testing is also something like the so canary, but it based on some specific conditions, like geographical locations. I want to release a new update only to only a new update to. It's mostly the application world. Okay, so mobile applications generally go with this A/B testing. So like so only like let's say the Play Store is common, like Android Play Store is common, but only the US people should get the update, but not the Indian people. Okay, or the Australian country only should get the update, but not the China. Okay, things like that you can just define. So that mostly, under specific condition, only male users should get update, not the female users. Yeah, there is also one of the condition in AB. Okay, so kind of way they do that. Okay. So shadow is basically you have version B and version A both, right? Now, what is the thing which happened here is, so which is a rolling update, which is default in this one, but we can also change that. And also change that to recreate. Okay, how do we do that? We'll see. All right, come back here. So create a deployment, to roll out a replica set. What you are actually rolling out is a replica set. You're thinking the application, but technically talking, it's rolling out a new replica set, right? So that's what it is. And declare the new state of the pods by updating the pod spec template. If you want to update those particular changes to the pod, so then you go for this and roll back to an earlier deployment to revision. So now what happened is you moved between versions to versions, right? 3 versions you moved. Now how can you do that is you can move or you can go to or you can understand. So here rollout so you can go for kubectl rollout status, here kubectl rollout status, and it's actually going to be the deployment of Nginx deployment. So successfully rolled out. Rollout is successfully rolling out, but we are not giving anything, right? Okay, you set the image and rollout. Okay, so this is not really needed. No, you want to go for history. Yeah, rollout history of this one. I want kubectl rollout. Okay, you just look for the status and the history of this one is actually it is telling there are 3 revisions happened. There are 3 revisions happened, and you want to switch to any revision, you can go back and apply. You can roll back easily now. Now let's say I do some rollout, and I think like so this app is having an issue, and immediately I can roll back. Okay, how can I roll back is you can go to here and you can just go for and roll back. So roll back to an earlier, that is also another use case, right? Roll back to an earlier deployment. And how do you do that is you have a command here, come down, checking your rollout history. You check the history and you can go for rollout history. Okay, so you can go for so hyphen revision is equal to 2. Roll back to the previous version. So here undo. Yeah, all these commands are decided to undo the current rollout. Okay, so kubectl rollout history, and this is the one, and a hyphen revision is equal to 2. So whatever the revision 2 of the deployment config you have, so that particular version I want to roll out. Okay, so okay, this is just showing rollout is actually showing, and if I want to actually roll out, no. So what are the rollout options you have? Okay, rollout is once it is done, you can check only those things. But if I want to go back, right? if I want to go for rollback, there should be a rollback option. Let's check from the kubectl. Kubectl, enter what all the options I have. Manage a rollout of the resource. Okay, only rollout is there. All right. So kubectl rollout, and what rollout is telling? Rollout is telling, you can roll out on deployments, daemon sets, and stateful sets. All right, which is fine. And rollback undo, rollback status, and history, pause, and restart a resource, resume, and status and undo. But if I want to go to previous revision, okay, so then what is the option? No. There should be something else. I'm not reading it properly. Okay, I don't really remember the option, but something around here. Let me just come from starting. So updating a deployment, you do kubectl. What we did is we updated the YAML file, or else what you can do is kubectl, you can give a message saying that, record. Okay, that means record what you're doing. Okay, so in our case, kubectl actually rollout history is showing empty message. You see this? Yeah, just history if you take. So it is showing the change cause is actually just showing empty, right? Since we updated the YAML file, or else if you update from the command line, so then what it is going to do is it's just gonna show you, if you go for history, it will show you properly why it actually, been, or how it is actually, or why it is being updated. Okay, kind of information you will get it here. So where is this history? Yeah, checking out. You see this change cause will be shown properly if you just use that hyphen record option. All right. So okay. So now the next one is going to be is rollback, right? Rolling back to a previous version and roll out, undo, and this particular one, it actually should be going to roll back. Okay, rolling back. And so roll out, undo, hyphen revision to this. So this will, so this will go back to the previous version. What you are actually doing is, so kubectl rollout undo, okay, and you're telling to this deployment, to this version you're actually putting. Now let's say if you want to go to version 1, you will say version 1. You can switch to any version of your choice now. Since there are 3 revisions, okay, you can go with any revision you want. Okay, so the rollback is a kind of a super simple here. And what is the default mechanism happening there? Rolling update. Okay, and now if I want to do something around a change here, but I don't want this, like let's say what are the options out there? First of all, with the rolling update, what are the options you have? Generally, what are the options we see? We'll see them, but let's try to complete this documentation of the use cases. Scale up the deployment to facilitate more load. Of course, you can do that, right? So kubectl scale you can use always, or else you update the YAML file. So kubectl scale, and this deployment hyphen replicas is equal to 10 if I give. So automatically on the top you can see that 10 pods will be coming up. So you can do that, so if you want to scale up your dynamically, you can do this. Pause the deployment. So sometimes while the deployment is happening, if you want to pause it, you can do that. Okay, if you want to pause the deployment, okay, stop it. Okay, I want to verify. So what has happened? At least with the one, so with one pod, whatever is being scaled, I want to stop there and I want to proceed. Okay, so that is where you can do this. So now let's say if you go with the revision 2, and so let's see how can you pause it, pause the deployment. They're telling, right? Get deploy, get RS, rollout pause. Okay, this particular deployment. Okay, so this particular deployment, right? Yeah, if I go to 2 version, so automatically it should start doing, or you're already in 2 version. I'll go for 3 version. Yeah, you're getting it right. So now if you want to pass it, you just pass it. Okay, so the deployment has been passed, and you will see the pods. Some are with one replica set, some with another replica set. I think by this time everything you got it. You see this, everything you got it. Everything you got it. Okay, so we can control this. First I want to do is I want to control this. See, everything just like that I don't want to happen. I want to go slowly, not parallelly everything, and that is where I can control that by using max surge. Yeah. So rolling update deployment, and so the deployment updates of a rolling update fashion can you can specify max unavailable and max surge. I think I had one documentation. I close that up. Okay. So here, so max surge. Okay, what is max surge? Basically is max surge Kubernetes deployment. If I could take you, I just got one documentation time back. Blue metadata. Yeah, this guy. So you just kind of explain the formula, right? So you'll understand it. Now, max surge is what basically the number of pods that can be created above the design number of pods during an update. So that means, like, let's say you have 8 desired pods in the replica set. Sorry, in the deployment you have 8 is the number you mentioned. The surge, it always goes and tries to create 2 pods. It always try to make 2 pods. Okay, it makes +2 pods, and it removes 2 pods. So under how many to remove, that is max unavailable. Okay, so how many to remove is maximum, max unavailable. So max surge is this. Now by default, now my deployment, if I go for deploy, and if I take you to the YAML output, there is so here you see this, the strategy. The strategy is actually happening 25% of is happening. So that means 25% will be updated, 25% will be updated, and at the same time 25% will be deleted. Okay, so I can control this as well. So what I need to do is I just need to update this particular strategy in my YAML file. Okay, let's do that. Let me delete the deployment. If I go for spec, and I can say that this is as a strategy. So the strategy can be, yeah, strategy can be type. Now what this is actually doing, the max surge is 1, max unavailable is 0. That means it first makes one new pod, and if it is fine, then only it will delete the old one. Again goes with 1, goes 1. So previously 1 means what is happening, the 25% means out of that 25% will be creating, at the same time 25% is deleting. The two things or operations are happening in manual, I mean not in manual, in sequential, okay, or in parallel, not sequential, in parallel. So that is where I want to control this now. And how do I control this is this. And the kubectl space pull, all came to running, right? Now some change. Let's change the version only. All right, so now let's try to do this. Let's try to do the Apply the change now. If I do the apply the change, all the things are not happening. You see this one by one, one by one, one by one, it will happen. So while it is creating one, it is deploying the other one. Okay. So it only goes with one by one, one by one, one by one. It is not just that fast like previously, however it happened. Okay. So it's slowly, okay, one by one, it is doing. So what you are actually telling here is, so you can control this by using how many number of things you want to make it, and at the same time, so how can you keep the max unavailable. Now let's say if I say max search is 5, okay, assume if I say max search is 5, so that means 5 lines, 5 pods will be created at single shot, and then those 5 will be deleted at the later. Okay, so that means 0 means so 0 unavailable is basically is unavailable should be 0 during my update, and after that it will clean up and maintain the number of replicas, right? So I will just go for 6 and push this. Now what happens now? So you see these 5 pods are actually getting created, and once those are coming into running, the other, so those 5s are actually, it just maintains the number as well, and it will delete. So, and ideally, what is the thumb rule here? Your max search always should be greater than your max unavailable. Like let's say if I give 10 and if I see max search as 1, so then what happens? All the 10 pods will be deleted in a single shot, isn't it? I'll go for 17. Push this. Go with this. Now you see this, lot of first terminated, then it is creating. All got terminated, then it is creating, right? So ideally, it has to be less than max search. Never keep more than that one. So that always brings some downtime. Is that clear? Any questions?
So Raghu, this max unavailable, we need to specify the number, or we can simply go with the 0.
You can stick with 0. See how many you want to delete while you update it. That's it. That's the strategy.
Okay.
If you make 0,
So
so
if
that
I
means,
have, yeah.
if you make 0, then that means what happens when there is a successful deployment, then only it will actually delete it. Okay. So for an example, okay, just for an example purpose, so I will make an image which the image doesn't exist kind of thing. So Kalluru, so which this user doesn't really exist. Now I go with this one, and now what's really happens, a kubectl apply. So the new pod which is going to be all the time, it's never gonna happen. Error pull image, right? Error pull image. So that means this pod is unsuccessful. So that's the reason this max unavailable is not coming into picture. Now you see this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 10 running pods are still there. Okay, but the new pod never came up successfully. So since the new pod didn't came up successfully, what is really happening? The max unavailable actually is actually equal to 0, and that's why the old pods are not getting deleted. So if I go with something like this, and I will just update this. Okay, so now what's gonna happen? Now let's say if I go for, so this user doesn't exist, right? So now if I just say max unavailable is 10, so that means 10 pods will be deleted, and your new pods never comes into so running state, and ultimately you will be having a downtime. Okay, all pods are into it'll go into error state. Old pods are deleted. Every pod now which you have is in error state. Your application has a downtime. So that's the reason. So always try to maintain a less number than the max search, and ideally 0 is also good. Okay, it goes one by one, one by one. That's it. Nothing more than that. Make sense now?
Yeah, yes, Raghu.
Any other questions? Okay. the next thing which you have is there is another type also, depends upon your requirement, you can go for another type. So this is most commonly asked interview question generally, right? What is the default rolling strategy or default strategy update strategy in deployment? Okay, so the default is rolling update. Also you can change that to recreate. So the type also you can go for and say it is as a recreate. Okay, so just for demo purpose I'll make one more file, 2, and I will say this as recreate. Okay, so if I say recreate, -02.yml, so the strategy is recreate now. Since the strategy is recreate, okay, so 10 pods are there. So now if you say recreate, so then I'll say 1.18, okay, and push this. And if I go and apply that particular 1.18 now, enter, and now you see this, what happens? First it will delete everything, clean up everything. First it ensures it comes to 0. Then it will do the deployment. If this is the case you're looking for, then you go for recreate. Okay, but ideally I don't prefer this going there. Why? Because it has some downtime involved. Okay, so since that is the reason, so we might not be interested in this, right? So recreate, we are not going to be interested in this. Make sense?
Yeah, yes, sir. So normally, what are the other types like canary and blueprint will be preferring, or only rolling update?
See, it's all you need to understand what is the thing you want for your business. There are all types are available. So which suits you most for your business? You have to pick that. So okay, so you want the high availability at any cost, blue green, or you want to so make the changes faster and you want to save the resources at the same time, then rolling update. So you want to cautiously release, like let's say only so some percentage I want to release and I want to stop there and I want to proceed with the remaining percentage, so then canary. Okay, so understand the business need and decide what you want.
Okay.
So Kubernetes deployment, yeah. So canary is basically what you can do is you can, once after you update one, you probably can pause it. Okay, so that become a canary, ideally, right? So once the deployment is happening, you can just go with the pause option, then it pause there, and you can go and do that. Okay. So now let's do the pause part. Okay, so we have, sorry. Let's go back to 1 now. So we are doing 1.10.0. Okay, fine. So kubectl -f 01.yml. So you have everything. Now, since one by one is happening, so what you can do is you can pause your deployment. Okay, so pause your deployment. And this is what is gonna happen. And now I want to make some change, which I want to put it as 16 version. So push this and do this. And next, once after this is done, I want to pause the deployment. Okay, and I'll say that pause as a deployment. So then what happens? Okay, it just paused. Deployment is paused. I mean, rolling update is paused. So now what you're going to see here is you can see this. This is one replica set. This is one replica set, like so ending 989, but also B78. So now you have two things also in place. Two things also two replica sets are there. Go for RS. You have this. So you have 4 and 7. Okay, and this is what happened. All right, so you just pause the deployment, so that becomes a canary. That becomes a canary. Okay, so now you can go for weighted deployment in Kubernetes. I think on the Kubernetes level, it is not possible. So that is the reason we go with something called as Istio and all this. Yeah, Istio. So basically, if you go for Istio and all, you'll get this weight. Or you have from Kubernetes, there is something called as OpenShift. Okay, so OpenShift also it is possible, but only on the Kubernetes native way, it is not possible. Yeah, that's okay. And it's also a good link actually. I understood. Diagrams are quite interesting here. If you want to see them. Explanation also really nice. Let me update this in documentation. And what are the other use cases it is telling? Other use cases, pause the deployment is fine. Use the status of the deployment and indicator, rollout has stuck or something like that. You can see the states, and also you can, clean up your old replicas. The replica sets you don't want them, you can clean it up. So generally, when you do a lot of updates, I can show you here. So something like this. If I go with the deploy, so how many times it has been deployed, you will be having a number not here. Okay, so probably I can go for Helm, and it shows me that there are so how many number of updates. So you take this particular service, you have 31. You take this service, 94 deployment, 94 revisions are there. Okay, so Helm is kind of giving that information. So 31 releases are there. So you can go back and release to whatever the one you want to do that. So which is fine. My point here is, yeah, so there will be a lot of replica sets. There will be a lot of replica sets. You see this replica sets, there are a lot of replica sets, so you need to start cleaning up these as part of your job as well. There will be a lot, and yeah, so you need to, if you don't want any unnecessary things, you can just go and clean them up as well. Okay, that's the idea. Okay, so yeah. I think that's about the deployments and the deployment strategies. And based on these particular, all these components whichever we talked about, we can run some project. Okay, and there is one more pending topic which you have over here is some CRD. Okay, custom resource definition. So in here, so I want to talk about that. So it's only more like a, so just a theory part I will just talk about here, which is fine. And so yeah, so there is one pending topic which I need to give some clarification around PV. So persistent volume, so we had some confusion on that day. So I need to give some clarity on that. That is one pending topic. And so tokens is something in pending. Okay, so which we'll talk about that in later there in the next section. But here, what missed part is health checks. So today let's try to talk about the health checks. And we will have a health check, and we will okay, so okay.
Just one question.
Yeah.
Are you going to implement that blue-green deployment strategy in
Yeah,
this
so we can
lab?
try that. Yeah.
Hmm.
But with the helm chart, I don't want to do it in a plain way. It becomes a
Okay.
complex.
Okay, got it. Thanks.
So yeah, now I would like to talk about health checks. See, if I am actually bringing health check Kubernetes. Now, if I'm bringing my pod, okay, how do I ensure that, so I should go and, it's ready for serving. So sometimes it takes a lot of time for booting. Okay, sometimes it takes a lot of time for booting. Okay, so and if you have that particular booting time and things like that, okay, so what you can do is for an example, if I let me show you something. Okay, so here some, so some parts, like let's say I have some Elasticsearch, right? So I killed this pod. Okay, literally I killed it. So now this pod actually comes to running, but it will not be ready. Okay, you will see that. So the pod come to running, you see that it is running, but it is actually not ready. You see this 0 by 1 ready. But who is actually determining whether that is ready? It is getting ready or not getting, so whether it is ready or not ready. So who actually telling that? Okay, there is some health check configured for that. Okay, and that is actually telling, okay, it is ready or not. Now you see this, it is ready. So sometime back only it came to running, but it's not ready for serving. Okay, and it took some time. So, and all these particular configuration, I mean, all this time, I don't want any traffic going there. I should not have any traffic going to that particular pod. Okay, how do I stop that? How do I stop that? So that's where the health checks comes into picture. All right, and those particular health checks are here we'll go to the pods, and you have two types of health checks. So one is a readiness probe and liveness probe. Readiness probe is when the pod is actually getting, while getting created. Okay, so you need a health check whether it is ready or not. That is a readiness probe. Okay, so 13.yml. Okay, so readiness and liveness. Okay, so readiness is while creating a pod, and the liveness is after coming to running. Okay, so then need to validate whether that is good or bad. Okay, in that particular case you go with this liveness. All right, and so let's go with configure liveness and readiness. So this is some example they have given, so which it is going to go for say this. So pod liveness exec liveness. Okay, this is liveness, right? Liveness means once it comes to running. Okay, so then it will decide once after it is running. Okay, so what they are doing, the health check is actually happening, liveness probe is actually happening by executing a command cat/tmp healthy. So they are going to execute a file. If that file actually generating some proper output, then okay, it is fine. So otherwise, if the file is not there, our command is actually giving some non-exit status. Like let's say if you remove that file, what happens? If you remove the file, what happens? So the cat command will throw no such file or directory, throws an error. Error is basically, so some exit status, and pod will get restarted automatically. The container will be recreated. This container will be recreated automatically. Okay, let's take a look on this. So the pod actually coming to running. The pod came to the running. Okay, which is fine, and the restarts are equal to 0. So now what it is doing some health check, and for 30 seconds it is fine, but after 30 seconds they're removing the file. Okay, so then what's going to happen is okay, so the health check is also happening, like initially wait for 5 seconds, and after that check the health check, and after that every 5 seconds do the health check, you're telling. Okay, now in some time, so what it happens is automatically that goes to restart. So the container health check will be checked automatically, and if that is no good, then it will recreate the container once again. So that's kind of a health check. We already seen this in the container world, the Docker container world, but so it's more useful here, not on the Docker container level. So it actually shows the restarts here. It's been almost 75 seconds. Yeah, now you see this restart. One came in. One came. Okay, how does it happen? The health check failed. The health check failed. Okay, so I think we can just do some work here. So kubectl apply -f debug.yml debug.yml, and the debug pod also will come, and the kubectl exec-it, go for debug and go for bash. Yeah, you're there, right? Now let's make our own another pod. I can go for some image first, directory. So liveness, right? Liveness. Okay. So here new file, Docker file. So from CentOS run yum install httpd-y and copy run.sh to slash. So run chmod plus x2 slash run.sh, and the cmd is slash run.sh. All right, so this is what you have, and ultimately you require run.sh, and in the run.sh what I'm going to say is so run.sh, and here bin slash bash, and so here I am going to httpd-d foreground, but I want to put this to the background and sleep for some 20 seconds, and then what I'm going to do is I'm just going to go for pkill command will be there. Pkill, yeah, pkill httpd, kill all the httpd process. It's pull cd images, cd liveness. So docker build -d slash dot. So docker login, right? It's already there, I think. Docker push, do this. Okay, docker login. Okay, so now coming back to here, and now I wanted to use this, and this is live test httpd, and args is not needed. And liveness is also, I don't want to do this, I want to check a port number. Okay, so because this opens a port number, so here ports, a container port, it actually opens 80 port. Okay, so that's the win. And also now down. So this liveness, actually previously you executed a command, so that is one approach, and at the same time you can also check the HTTP request also. Okay, since that is a HTTP pod, you can go for healthy HTTP get and just give slash, and so if the slash, then on the port number 80, everything is okay, so then we consider that. And after 20 seconds, what we are going to do, we're just going to kill the HTTP process, and that's where it's gonna just, it's just gonna it's just gonna fail. Okay, let's see. So now that is getting created, so that comes with one IP address. Now while true, do curl done. So now I want to sleep for 1 second. Every 1 second I want to do, and slash null, or probably I head hyphen 2 lines. Okay. So now what's really happening there? Something wrong. So call that particular URL. I had 2 lines. Update command. First of all, it's coming only, no problem. Okay. Okay. So currently it is crash book look, crash look back off, which is fine. So but automatically it just gets recreated. Okay, if you wait for some time. So now it came to running and you're getting some response. You see this? You're getting some response. You're getting the response. Okay, you're getting the response, and after some time again it goes to fail state, and it's automatically recovering. You see in a status of crash back loop off, and automatically it is getting restarted. So how it is getting restarted? Because now you see this again, it is failing, connection refused. Okay, so it automatically gets recovered automatically. Okay, so that's the whole idea about liveness. So while the pod is running, so it, you want to check whether it is good or bad, and based on that decide to restart your container. So that's where the liveness comes into picture. And at the same time, so when you want your application while booting it up, okay, so when you want to boot your the new pod is getting created at the creation of time, you want to consider, yes, my pod is ready now, kind of thing. So then that is a readiness. Okay, readiness and liveness probe, we just do it generally, and based on that we'll do that. Now using all these particular options, what we're going to do is we can just go and write our application. So previously we had some small project, right? So we can go and apply this particular knowledge on that particular project, and we can do that particular project. Okay, so that's the idea, and we'll go there. Any questions? Okay, so now it is been enough, so enough learning. So let's bring that to action. Okay, so with the project which we're talking about. So what are the projects which we have there? I mean, we have one project, but what are the components does it have? So it has one front end, it has a couple of backend components, and it has a couple of databases, right? So and so which one to choose and things like that. So we will go with that now. All right. So let's go to the here and go to the repos. So here every component is already being configured here. Okay. So and all these particular components, let me bring some connection between them. Okay. So or make a diagram for them, or I already have the diagram. That receipt chart. I didn't make any project diagram. Huh? Okay, fine. So let's try to. So here we are going to have the components. So what are the components we have? First is front end, and this front end will talk to 5 components in the back end. Okay, so one is user service, and the other one is catalog service, and the other one is a cart service, and the other one is a shipping service, and the other one is finally is a payment one. Okay, so now in the backend you're going to have another component, so which is MongoDB, and you're going to have MySQL, and you're having Redis. Okay, so you're having Redis, and you're going to have something called as going to have something called as RabbitMQ. Okay, so these are the components which I have, and so from here I have to connect. I'll be connecting to all the components, and these components are certain components like user will talk to Mongo, and user will also talk to Redis. Okay, and the catalog will only talk to Mongo, and cart will talk to only Redis, and and then shipping will talk to MySQL, and payment will talk to RabbitMQ. Okay, so this is the backend component, and front end will talk to every component here. So here to here, and to here, to here, here to here, and finally, so the public traffic. So the public will hit this. Is the idea. They will hit this, and ultimately we should be getting it. Okay. So now I need to configure. So since this is a MongoDB, this is a database, right? So you require persistent volume and things like that. So what you can use, so here in the words of, or in the terminology of, so in Kubernetes thing. So then what I can use here is I can use this as a which one I want to use, or what are the components would come into picture. Shall we talk about the components of Kubernetes which comes into picture to talk, to deal with this Mongo? So Mongo, does it require some? What I'm thinking here is here. There it is. It requires a stateful set. Can we do this now? So that means for each, not do this in the sense like what we need. Can everyone participate? Like what all the things you might expect to come here? A stateful set is needed. Stateful set come into picture. Any other components, whatever we have discussed, is come into picture in the case of MongoDB. So probably a service comes into picture, right? A service, an endpoint is needed to hit this particular Mongo. So that kind of a service is needed, either whether it is a headless service or something. And do you think anything else?
Health check.
Health checks is a part of stateful set, and again, it's a health checks also you can keep it. Health checks, and what else? Okay, so I'm also not quite sure, so just put that much there. And the same thing applies to MySQL as well, and the same thing applies to Redis. Redis, whether it goes with stateful set or whether it goes with a deployment, I think stateful set is also fine. We can use that. Okay. And whenever it comes to RabbitMQ, I think RabbitMQ doesn't really require a stateful set, so probably I can go for a deployment also. This works fine. So because that's not a database service, it's fine. Okay, health checks. And so this requires some username and passwords, right? You need to configure some user and things like that. So that's where I'll go for secrets. Okay. And does it require any configuration to be loaded? I don't think so. So which is not needed. So Redis also doesn't have anything, nothing. But MySQL also should require some secrets. Okay. So a root password kind of thing is needed, and as well as the application related username and passwords also is needed. Okay, which is fine. Now here, when it comes to the user, okay, the user is actually going to be by using a deployment, okay, a deployment, and also it requires a config map. Okay, it requires, it need to contact to the database, and database information should be there in the config map. Okay, so that is where I'm going to write a config map, and also it ultimately requires a service, and health checks will be there, and health checks will be there. And is that all? And for this, we talked about this many. Health check. Okay, so probably all this service account and all these things comes into picture. So service account will be creating service account. What else? Let's go and refer here. Yeah, so here PVCs, we missed that. So for everything you require a PVC. Okay. So this also you require a PVC. So you want to persistently store the data, right? This also you require PVC. For RabbitMQ, I don't want it. Okay. So for this one, I don't want it. What else? Networking labels. Namespaces. The whole concept wise, namespace is needed. That's fine. And yeah. So sidecar containers also comes into picture. So I'll talk about that. But very plain way, service account, and what else? Service account, and it is common for everything, by the way. Okay, not only this, for everything it is common. Service account, and so you have sidecar containers. Sidecar containers, but there is another concept called as init containers. I might have missed talking about init containers. Yeah, so I should add the here also. I'm missing it. So something about init container, I will talk about that as well. We also need that, so going okay. Init container also we need, and this is the one. What else? Health checks, resources. Resources, you are missing resources all the time. So for everything it requires resources. Even here also. For everything we require resources. We want to give some resource. Okay. And what next? What next? Port exposing image policy and all these multi-containers, pass containers, execute commands, and all this is fine. Okay, fine secrets, volumes, no definities. Record containers, backs, it is not needed. Replica set, yeah, fine. So these all needed, and the same thing is more or less is needed here as well. Okay, so but this might not require, and these also require secrets. Okay, so some username and passwords you require, and so this also is needed. Okay, so but here you don't require that one. Okay, this is the whole concept. Okay, so applying those particular tech stacks, we want to drive our application. So probably tomorrow we can see now running one by one component and what all needed. So for each and every component, we write a YAML file which has deployment, config map, service, all these things. Okay, so one by one. And ultimately, so what we are going to bring some add-on values. Initially of the session, we talked about something here, right? So what all the things we talked about here, so AEFS or is needed or not. Probably Web Shield. There's also okay, Secret Manager, and majorly ELK stack also we talked about, right? ELK. Okay, so we want to use that particular ELK here. And I want to send out the logs. I want to send the logs here. Okay, so that means ELK also comes into picture. So you go for ELK. Okay, so yeah, so from ELK I want to, so to ELK I want to push the log, so that's where the sidecar container comes into picture. All right, and yeah. Yeah, cool. So we'll see. Practically, it will go 2-3 days. Okay, easily it will go 2-3 days. You will understand some concept and you'll find out the pain, and that's where the Helm chart is actually bringing you solution. You'll understand that, and we'll jump onto the Helm chart, and or before to that, even the cluster concepts. Okay, so I mean, cluster is basically the Kubernetes concept. We'll try to cover that. Just takes 1 or 2 sessions. It's more of theory part. So less practical work, part four, and then we'll go on to the part 5. Yeah. All right. So that's the idea. Clear? Any questions? Okay. All right. No questions. We'll meet in tomorrow's session and we'll continue there. Okay. Thank you. See you tomorrow. Bye.